Hello, here the new video where I will show how I integrated the soil moisture sensor with the solar panel, battery and Wi-Fi to make it wireless. As you can see, I also 3D printed the case for the equipment and to hold the solar panel. Here you can see the first sensor going to one plant and the other sensor here. So I put two sensors in total. And this will use Wi-Fi to transfer the data using MQTT protocol. For this implementation, I wrote an article in my website, and there are all the instructions how to set up the system and what I use as a battery charger, solar panel, software, controller, and batteries. So it's a complete tutorial. In this video, I will go through the various steps. So let's start with sensors and Wi-Fi. This integration is done using the sensors, the soil moisture sensors that I designed. So you need one or two or three of these. And then for the Wi-Fi connection, I use the ESP chip, which is very famous. Indeed, they come in different packages. I made two different setup, one using the Wemos D1 Mini, which is this one in the picture, and another setup I used this one that is called ESP01. And both of them use the ESP chip 8266, if I remember correctly. There are some differences between these two packages. And the most important is that the Wemos has the USB, so it's easier to load the software into this device, while with the other device, the ESP01, you require an adapter to program the chip. Then there is another difference. The Wemos D1 expose more GPIO pins, so indeed is also it make it easier to connect the sensor, and most important, the GPIO 16 is exposed, so it's easy to connect it to the reset. This connection is necessary because of the deep sleep feature. If you use this one, the ESP01, you have to solder one wire to the very small pin of the chip and then go to the reset. So it's not very convenient, I would say. So the second step is to load the software into the ESP so it can be programmed. And for this, I use Tasmota. Tasmota is an open source software, but unfortunately at this stage, Tasmota does not support my soil moisture sensor. So I had to do some modification to the software. Here you can find the link to GitHub where you can find the software that support also the sensor. Let's open it and see. Yes, is this file. It's just one file. It has modasensor.bin. Okay, so you have to download this software. You will use later to load into the ASP. The Tasmoda also provide a software that is very convenient to load the Tasmoda software itself into the ESP. And you can find here the link. It's called Tasmotizer. I use the installation for Linux system. And then you, when you launch the program, you have this interface, and you have to choose the file.bin that we just downloaded. You have to tick erase before flashing box, and then you can tasmotize, so to load the software. So once you have loaded the software into the device will reboot and will start its own Wi-Fi. So you have to connect to the new Wi-Fi that is generated by this device and type this address in your web browser. You will get this interface. And first of all, pay attention to type exactly this address and with MQ at the end, because you will enter the MQTT setting. Of course, you have to have somewhere the MQTT server. In my case, this is the address, the local address of my MQTT server. Then I left all the other parameter unchanged. And the very important part to remember is the topic. And here you have to put a name that you need to remember because it's like an address for the MQTT. And that's it. You save, then it will reboot, and you connect again with its own generated network, Wi-Fi network. And this time you open the browser and write this address, and you will get the setting for the Wi-Fi. So you click scan for Wi-Fi networks, and hopefully you will get your home Wi-Fi network in the list. You click on that, you put the password, and that's it. You save. And at this point, the ESP will reboot and now will connect to your home Wi-Fi network. So the first step should be done now, and the ESP should be connected to the Wi-Fi network and should have also an MQTT. For the MQTT server, in this particular case, I use the Hydrosys4 software, which is an open source software for irrigation and environment control. So I use this one because I'm also the designer of this software. But anyway, you can use whatever MQTT server and software. For example, you can also use Home Assistant if you are familiar with that software. Here in this chapter, we have the Hydrosys4 software integration. So first thing, you have to have the Hydrosys4 installed on the Raspberry Pi. So you enter the web interface and go to edit table and add the required parameter. Not all the parameters are necessary, of course. You can refer to the guide and you will see that only few of these parameters are necessary for the setting of the MQTT. And as you can see here, I have also several of them that for example, this one that I already set, as you can see. So let me discuss about parameters. So the most important parameter is this title. Indeed, the title is like the topic MQTT with additional string. So to compose the title, there is this string which double backslash. And so before the double backslash, you have to put this tail, then the title, the topic that you choose and you put on the ESP, you have to put here, and then sensor, then double backslash. And then after the double backslash, you have to write slow wire dash, and then here the GPIO number of the ESP where you connected the sensor. When this is done, you can check that the sensor is connected. In my case, for example, we can go to setting and show MQTT clients. And here I have several clients, and these two, as you can see, has an IP address. The other is not available, just because the other have 30 minutes deep sleep. So indeed, it's very rare that you can catch the device when it's not sleeping. This other device, that as the others finish with 38, I didn't apply yet the deep sleep. So you can easily see the IP address. If we go to this IP address, we will see the Tasmota main menu. And here it is the address. You can see that the device is transmitting the humidity data from slow wire 1 and slow wire 3. And these are the two sensors that I have connected to this device. How did I set this device? I just went to configuration, configure module, I configured it as generic 18, and then I connected the soil moisture sensor to GPIO01 and GPIO03 by selecting the slow wire in this drop-down menu. So slow wire here and slow wire here. And that's it. If the configuration is working, then you will get two numbers here and here. On the other side, so on the Hydrosys4, you can go to setting and check if there is any reading. For example, here we can see. So we can see that this is getting the value, and then the last update was 237 seconds ago. This depends on the interval that we set for the reading of the sensor. I think here I put 15 minutes. Good, so everything now is working. Let's go back to the guide. Well, as anticipated, here in the guide there is a mode setting and configuration. Indeed, it's not possible to use all the GPIO pin of the ESP because several of them interfere with the boot procedure, and we want to choose a GPIO that is not interfering with this. So I choose with the Wemos D1, I choose GPIO 4 and 12, for example. One important part is to set some option into the task mode. These three options that are quite important, especially if you have a reset or you have several reset of the device. It's important to set this option in the way that it doesn't lose the configuration. And also the deep sleep. The deep sleep means that the device will consume very little power when in sleeping mode. So let's assume here we put 1800 seconds, that is 30 minutes. And it means that for these 30 minutes, it will have very low drain on the battery. How to set the option is very easy. You go to the task mode, console, and you type here the option. For example, set option 65. We write here, and you see set option 65, and then you say that set option 65 is on. Great, so we can do it with all the three options. In this part of the guide, we will see how I set up the solar battery system. So I use this battery charger module that is based on this chip, the TP4056. There are several variants of this chip and package. So I use the one that has the input here and the battery here. So the cable goes to the battery. And this is specifically done for this type of battery, the 18650. I found them at very good price, I would say, and they have also good capacities. Here there is another package that make exactly the same function. The other component I need is this 1S battery protection module. This is especially done for the 3.7 volt battery that is exactly this one, the 18650. And then the solar panel. In the guide there are also two models of solar panel because I made two configurations just to make some experiment. Indeed, when I use one configuration, I see that the panel was maybe over-dimensioned. But we have to take into consideration that I also live in Italy, so where I live is quite sunny, so maybe other countries require bigger panel. Here is the wiring schema. So solar panel, go to the battery charger, and then the wire go to the battery, and then the battery protection, and then exit from battery protection and go to the ESP. To complete this project and then to make all the components, I also 3D printed the case that included the electronic inside and the support for the panel. Here there is the link where you can find the files if you want to print them. Here is the link and the files with all the components. I recommend to use PETG as the filament because the PETG is better to stay outside, and that's it. Here's some picture and some data that I collected during the time. I also put some specs for the ESP, specific for the ESP01 and the GPIO I used, the welding I had to make for the GPIO 16 for the deep sleep mode, and other notes that is worth to remember. And here we can see the electronic inside the case, and so the batteries. I made a small board to host the components. Then we see the cable that go to the solar panel, and the cable go to the battery, and the other two sensors that I connected to, yeah, using these connectors to the board. You can see there are the rails that are used to mount the solar panel also, with holes at different distances in case you have different sides of solar panel. And below there is also support that is meant to be attached to a pole so that it can stay at 45-degree angle, something like that. So the water should not be able to enter the lower part of the case, even if it's not isolated from water, should be okay because the gravity should not allow the water to go in that direction. So here I finish to put everything, and then I put the cap over it. And this is the final result. Hope you enjoy it. Thank you for watching.